Hi, welcome to my second video of teaching Algebra 1. Today we're looking at chapter 1.2, which is about solving multi-step linear equations. In this lesson we will learn about two variable equations and multi-step equations. We're also going to learn about solving real-world applications of these problems, and we're also going to learn how to model problems that involve linear equations. In the last video we discussed what expressions, equations, and algebraic terms are. We also discussed the properties of equality, such as the addition, subtraction, multiplication, and division properties that I've listed here. In this video, we will also use the same properties that I did in the last video to solve equations. Before we move on to solving multi-step linear equations, we will first go through solving two-step equations. Here I have two examples of solving two-step equations. Let's look at number 1. So the question says we have minus 2n plus 3 equals minus 6. If we think about this question, we know that this side of the equation is adding plus 3. So to reverse this operation, we can do minus 3 on each side. And if we do that, the minus 3 and the plus 3 cancel out, and we're left with minus 2n. So we have isolated the variable n to only one term of minus 2n. And then minus 6 minus 3, which makes minus 9. And then this gives n equals negative 9 over negative 2. Which gives us 4.5. Now let's check if 4.5 is really the answer for our n here. We can do that by plugging this number back into n and then checking if the whole left side of the equation equals the right side of the equation. So if we plug in 4.5 here, we get minus 2 times 4.5, which gives us negative 9. And negative 9 plus 3 gives us negative 6, which means our answer is correct. Let's look at problem 2 now. So it's given that 0.5n plus 10 equals 1. To reverse this operation that we have here, we can do subtraction. So we would do minus 10 on this side, and then we would do the same thing on the right side of the equation. So that would become 1 minus 10. And then we do the whole sum, and we get rid of this whole thing, and then we're left with 0.5n on this side. Again, we have isolated the variable, which means we can simply divide after we've calculated this value. So this becomes 1 minus 10, and that equals negative 9, and then this equals n equals negative 9 over 0.5. And if we put negative 9 over 0.5, we get n equals negative 18. Now we don't know if this is actually correct, so we can put this back into the n that we have here, and then check if the left side equals 1. So negative 18 times 0.5, that gives us negative 9, and negative 9 plus 10 gives us 1. So we know that this answer is correct. Now that we know how to solve two-step linear equations, let's look how to solve multi-step linear equations. Well, if we look at this problem that we have here, we're given minus 2x minus 10x plus 12 equals 18. We know that there's two like terms of minus 2x and minus 10x, so we can add these together to form one term. So minus 2x minus 10x gives us minus 12x, and then we leave this constant here, so that becomes plus 12 equals 18. And then what we can do is subtract 12 from each side using the subtraction property of equality. So if we do that on each side, we cancel this out, and we're left with minus 12x equals to 6, and x equals to negative 0.5, because 6 over negative 12 gives us negative 0.5. Or if you want to write it like a fraction, it could be negative 1/2. Now we need to check if this is actually the answer, and the way we can do that is by plugging this back into the x's. So if we do that, we get negative 12 times negative 0.5. So we get 1 plus 5, which is 6, plus 12, which is 18, equals 18. So we know that this is correct. Now here we have another multi-step equation, which says x over 5 plus x over 10 in parentheses. So we know that we have to do this operation first. Plus 4 equals 0. Well, how do we simplify this expression that we have here? Well, we know that they have two different denominators, so we have to make it a common denominator. And the way we can do that is by making a common denominator of 10. By turning this denominator into 10 by multiplying the fraction by 2 on the numerator and the denominator. So if we do that, we get 2x over 10 plus x over 10 plus 4 equals 0. And if we do the addition here, we get 3x over 10 plus 4 equals 0. And now we can just subtract minus 4 from here and here using the subtraction property. So that will give us 3x over 10 equals negative 4. And then I think you know what we can do. We could just multiply 10 on each side to get rid of this denominator. And by doing that, we get negative 4 times 10, which is 40. And to find x, we can isolate this by dividing with 3 from each side, and we get 40 over 3. I'd leave this as a fraction because this is repeating decimal. Oops, I just realized I forgot the negative. This is negative 40, and this is x equals negative 40 over 3. Now that we know how to solve linear equations without any applications, let's see if we can learn how to apply the learnings that we have taken in this lesson, and then we can solve this modeling problem that we have. Well, the question is, you have a swimming program in which you want to determine how many minutes to swim for so that your average daily swimming time is 30 minutes. How many minutes should you swim for on Friday? Well, we're given a table here which shows our timings and the days on which we do the swimming sessions. So on Monday we swam for 40 minutes, on Tuesday we did 20 minutes, Wednesday we did 25, and Thursday we did 45. I'll walk you through this problem and show you how to solve this question and how to pick out the technical terms from this problem. We should make a list of how many minutes this person swam for every day. So we know that this person swam 40 minutes on Monday, and they did 20 on Tuesday, 25 on Wednesday, and 45 on Thursday. And we don't know Friday, and that's what we have to find out. Well, it says that the person wants to swim for an average time of 30 minutes. The key term that here is listed is the average. So we can make an equation using the mean formula, which is you add up all the minutes and you divide by the number of days this person swam, and you make that equal to the amount of time they want to average. So this would be 40 over 1 for that one day that they swam, and that 20 minutes they swam on this other day. You have to add the number of days that the person is swimming. So it'll be 1 plus 1 plus 1 plus 1, and the last plus 1 for the Friday. So this is going to be our denominator, and if you add these numbers you get 5. So for Wednesday, the person swam for 25 minutes, and on Thursday they did 45. And they want to determine how many minutes they should swim on Friday so that the average of the 5 days equals 30 minutes per day. And then we will equal this to 30 minutes, and then we just have to solve this equation for x. So let's add up the numerator. Well, 40 plus 20 is 60, and 60 plus 25 is 85, and then 85 plus 45 is 130. And then we're left with plus x, so we don't know what that is, so we just leave that as an expression in the numerator. So the numerator becomes 130 plus x over 1 plus 1 plus 1 plus 1 plus 1, which gives us 5, equaling 30. And then we can just use the multiplication property. So if we multiply each side by 5, we cancel this part out, and this equals 130 plus x equals 150. So we get x equals to 150 minus 130, so we can isolate the x. We get 150 minus 130, and x equals to 20. So 20 is the amount of minutes that the person should swim on Friday so that their average equals 30 minutes per day. And this is it for this section of solving multi-step linear equations. In the next lesson I will teach you 1.3, which is about solving linear equations which have variables on both sides. We will also learn about some contradictions and special cases which arise when solving some linear equations, and also some applications of those equations. Hope you liked this video and you found this video helpful. Please leave a comment and provide some feedback so that I can improve my videos, and thanks for watching.